So we are interested in the bottom 10%. We have a mean score of 200 and a standard deviation of 20. So 220. They actually do not give us the X in the context of the problem. They just tell us we're interested in the bottom 10% in cognitive functioning scores in older adults, so they can participate in the study. So this is interesting because we have to go from the percentage to the probability, and then from the probability to the Z-score. In the past, we've done the Z-score, we find the Z-score, and then we find the probability. We're going to have to do it backwards this time. This is what it would look like, the bottom 10% of the scores. If it had said the top, we probably would have looked at this tail, but that's not what they're asking for. So how much probability is 10%? So it's actually just 0.1000. Remember, you can go from percentage to decimal pretty easily. And also remember, the C table gives us the area from the Z-score to the left. So it works really well that we are interested in this tail right now, to begin with at least. So what we need to do now that we have the probability is find what the Z-score here is going to be. Because what they want to know is what X is. What is the lowest score that they can have so that we can find that bottom 10% of people with cognitive functioning, I'm assuming, issues. So from here, let's find the probability into our table. So the other thing you need to remember to make this easier for you is that the Z-scores can be positive to this side and negative to this side. So because we are in the left side, it's very likely, it's like 100% likely that the Z-score is going to be negative. So from the start, we can go into the negative side of the table and look for that Z-score. We'll look for this probability and then find the Z-score. Okay, I am in the negative side of the table. And inside these probabilities, I'm going to look for 0.10, basically. Kind of know where I am. So here it is, negative 1.28. That's the closest I can get to 0.10. And the Z-score is going to be negative 1.2. And then if we go up, follow that blue line, it's going to be negative 1.28. So we know the Z-score here is going to be negative 1.28. We know mu was 200. And we know that sigma was 20. Recall, the Z-score formula looks like this. We have this information, we have this information, and we have this information. Really what we want to know is what score for that test is in X. So the way I would do this is by solving for X. So I would move sigma by multiplying both sides by sigma. It will look like this. It's supposed to be multiplication as an asterisk. X equals mu. Oh, sorry, not equals, minus mu. The way I'm going to move the mu now is I'm going to add it to both sides. So it would look mu plus C times sigma equals X. And this is my new formula for finding the score. So you don't actually have to solve for X every time. Like, you can write the formula like this in your formula sheet, and that's what you can use. I just wanted to show you where it comes from. So X, it's going to be mu 200 plus parentheses negative 1.28 times 20. So when there's an implied 1 here, if you don't remember, whenever we do this multiplication, it's going to be a negative number. And then when we multiply the negative times the positive, it's going to be negative as well. So it's going to be 200 plus minus 25.6, which is the same once we do this implied multiplication here. 200 minus 25.6. answer for X is 174.4. So the lowest score to find that bottom 10% in the cognitive functioning test is 174.4.